is currently host?
Host is 24 hours of STEM producer, whoever that is.
And we are
Okay, we're going live
again.
Live, okay. I'll share my screen 1 second. Okay, Joshua.
Okay, so I think we can resume here, right? We're live and everything. We can resume.
Yeah.
Okay, Sanjit, if you could start the video over, I'll just. Yeah. Okay, sorry for the technical difficulties. So over here, the first thing we're doing is we're adding an image, uploading our sample image. Then we have to click the eye icon so that it's actually visible. Now, the first thing that the first operation we want to add is the blur effect. The reason this is important is it reduces the amount of pixels on the image and hence makes it more efficient to actually process. So we have to drag our sample image into the input of the blur. Then after that, we have to specify it to be a Gaussian blur. Once again, you have to click the eye icon to make sure it's visible. Once we specified it as a Gaussian blur, we set the parameter for radius to 25. Then we want to get the last operation of desaturation. This is important because it turns the entire image into just shades of gray, which make it easier to process specifically the brightness channel. Now we need to drag the output of the blur into the input of the desaturation. Once again, press the eye icon so the desaturation filter is visible, and there we have it, our image. Then to generate the code, we have to go up to Tools and then press Generate Code. So now once you press Generate Code, it'll open this pop-up over here. Make sure to first select the language to be Java. You can leave the checkbox unchecked. Then the pipeline class name will default to grep pipeline. So we'll refer to that later as by that name. The save location, it doesn't matter actually where you set this to, just so that you can easily find it. So just note what it is so that you can find that file later, because we'll be copying stuff over from it. And then the package name, you can leave it blank and then press OK. Now, once you've generated the code, you're going to have to locate it and then open it in any sort of text editor. Once you've done that, in Android Studio, you want to create a new class called image processing. And then in the greppipeline.java, the generated code, you want to copy everything from the enumerator blur type downwards. So you'll be copying the enum that contains all the different types of blurs. You'll be copying the blur method, which will actually apply the blur filter, and then the desaturate method. So all three of those will be getting copied over. And we'll show you how that's done. Oh, and I don't know if I specified it earlier, the stuff that you're copying over will be pasted into the new class that you created called image processing. So here we open it in a separate text editor. It really doesn't matter which one. This one's Sublime. We'll copy all the way from that enum downwards. As you can see, we've highlighted all of that. We'll do Control or Command C, and then once we create a new class, Java class, image processing, click OK. In the curly brackets, just press paste, and everything will be printed, will be pasted for you. You will get a bunch of errors saying that, oh, this type cannot be resolved. But all you have to do is click Alt-Enter or right-click on the error and press Import Class. These are just simple import errors, but your library has been successfully imported, so it should be able to automatically detect these for you. Okay, so now that we've pasted everything into the image processing class, we need to actually create a method in image processing called process. Now, although this method is called process, it won't actually do the processing of the image, but rather put it in more efficiently processable formats. It will actually apply the blur and the desaturate onto the matte input. So basically what this does is it takes the matte input, it forms a blur output and then an overall output. It makes it so that the blur output is the output of the blur, the Gaussian radius 25 blur. And then we take the blur output, then we put it in the desaturate input. And then our overall output is basically what we'll get from both the blur and the desaturation. And then we return that as the result of the process function. Oh, just this image on the bottom here will give you just like what this will basically do to your image. So you have this clear, crisp, colored image, and then we basically convert it to a blurred black and white equivalent of that image as a result of calling the process method. So now we need to actually find where the sky stone is. So as you can see, when we capture two stones in our frame, we can split them in half, and now we have the lightness value of one and the lightness value of the other. So when one is significantly darker, what we need to do is basically take the average value of each half, so each side of the image, and compare them. Whichever one's less is not the whichever one has a lesser brightness value is the sky stone, because the sky stones have a darker black color to them. So first we need to create this method called getValueBySide. What that'll basically do is it will return the average value of that side of the image, given which side you are trying to determine the average value brightness of. So we make a mat input and a Boolean for which side. So if when the user is using this method, if you're trying to find the left side, you would input true. If you're trying to find the right side, you would input false. So in order to treat this in a two-dimensional format, which means like finding the average, registering the average value of like every single pixel on the image, you have to create a nested for loops that you index through x and y. As you can see, we do that over here. We also initialize an offset such that if we're trying to measure the right side, we actually have starting point that's halfway through the image. For each iteration, so for every single pixel, we just increment the sum variable by how much ever the brightness value is, and then we also increment the count variable by 1. Then at the end, we do sum divided by count to get the overall average value of that one side. Now I'll show you how we do this in Android Studio very quickly. So yeah, once we paste that method in, we now have our getValueBySide, and it's there for later implementation. So next, we just need to make sure that we know how the stone positioning works. So the way we're going to be doing this here is all 6 stones are aligned, and we'll name them left to right as 1, 2, 3, 4, 5, 6. Now, what we're going to deal with here is actually selecting the sky stone amongst stones 4, 5, and 6. So we're not going to worry about 1, 2, and 3 for now. So now the first assumption that we're going to make is that our phone camera will be viewing stones 5 and 6, no other stones, just 5 and 6. And between those 5 and 6, we'll be able to compare, hey, is this one darker? Well, if it is, then it probably is a sky stone. But we still need a way of telling if the sky stone is in position 4. So to do that, we need to compare stone 5 and 6 and see if the average lightness values are close enough. So to do that, we need to use a color tolerance. As you can see, if they're close enough, it'll look like this image on the right where they're both gray. The reason we need a tolerance though is because they'll never perfectly be equal to each other because of environmental lighting. Okay, so over here, the first thing we do, create a private integer called color tolerance. Then in the process, we create a new method called stone position, where we call the process function, which will just put our image and apply the blur and desaturation to them. Then with that blurred and desaturated image, we get the value of the left side, right side, and store them into these 2 integers. Then we default this integer stone position to 6. Now, if the difference between the left and right side of the image are close enough, so they're less than the color tolerance, they're practically the same, then we know that the sky stone is in stone position 4. If not, if we know there's a significant difference between the lightness value of both stones, we compare, is the right one greater than the left? If it is, we know it's stone 5. And if we fall through all the if statements, our stone position is defaulted to position 6. At the end, we just return the stone position, and that's how we determine the sky stone. Over here, we'll just quickly demonstrate it in Android Studio, paste the method in. As you can see, it's all there, and it's ready to be tested in what we're going to do next, which is the actual test op mode. So to create the sky stone detection test program, we're basically just going to create a copy from Vuforia test, rename it OpenCV test, delete robot position, everything after telemetry.update, and now instead you'll add the image processing class and construct it. Then you need to call the camera's getMat function and actually apply that as the image capture, and then use the image processing's .stone position function to actually determine which stone it is and output it to telemetry. So now we're going to show you how this works. Once again, add a sleep to the end. It's highly recommended so that you actually have some time to process for you to actually see, hey, did this telemetry output correctly? Otherwise, it will just stop and erase all the telemetry text before you can even see it. Okay, as you can see, we pasted it in here and it is ready for testing. Go ahead and try this by yourself and you should be able to detect the correct sky stone, assuming that your camera is aligned on stones 5 and 6. Here's a quick demonstration of how it looks like. So as you can see, this is just the POV of the camera screen. Once again, you see the Euphoria watermark in the bottom left corner, just like Sanjit said. And this is stone 5 and 6. Stone 5 is the sky stone. And as you can tell from the screenshot on the right, the op mode successfully detects it as stone position 5 being the sky stone. And with that, you've successfully detected the sky stone using OpenCV.
Okay, so that's gonna be the end of our presentation. So congratulations, you've used 2 different technologies to accomplish using vision and FTC. So if you look back at our original definition of how vision can be used in FTC, we talked about as a sensor, which could be our OpenCV, and we also talked about as getting your location on the field, which is Euphoria. So we accomplished both of those tasks with these 2 different technologies. So as Joshua explained earlier, we use the phone camera in this demo, but switching to the webcam is not difficult. I'll just show you. If you look in the samples folder, right, you'll find there's a concept Euphoria Skystone navigation and Skystone navigation webcam. You'll see the differences between those are all the real differences that you'll need in your camera class. And that's the main difficulty comes from actually connecting the webcam to the robot rather than actually the software behind it. So also for our OpenCV, we use the Easy OpenCV library, and we didn't actually use what comes with it. We just used OpenCV like bare. So if you're using Easy OpenCV, the library has a lot more to offer, and we really recommend looking into that and like looking at it because it's really well made. And like you can do multiple camera streams at once. Then finally, the last point that I'm going to talk about is the method we used when like about the comparing brightnesses of like the left and the right side. That was what we found to be the most efficient method for this season for finding the sky stone. But like in Rover Ruckus, finding the gold, that method wouldn't work. So we recommend in that case that you use something called an OpenCV RGB threshold. So there's an operation for this in grip. Basically, it goes through every pixel, and if the pixel is in the range, it becomes a white pixel. If not, it becomes a black pixel. Then you can just find where the stone is or the gold is that way. So if you have any questions, we'll take some at this time. But if not, if you have more questions, contact our team at FrogForce at frogforce503.org. And then you can also find the code for this at our repository. So does anyone have any questions? Were there any questions?
So it seems like we currently don't have any questions in the online chat, and yeah, our time is pretty much that we're pretty much used up all our time. But thank you guys so much for that insightful presentation. And since we have no current, I'll give people in the chat one last chance to pop in a question. But if not, thank you guys so much for your time, and it was really cool what you guys did, and were able to present to us.
Yeah, thank you for having us. Like we're very grateful for the experience.
Yep, thank you, T971.
Yeah,
we just got a question actually.
nice.
What does OpenCV stand for?
Open
Might not be a
Computer
technical question, but
yeah, it stands for Open Computer Vision.
well, there you have it. Thank you guys so much for coming. And unfortunately, that is all the time we have. Thank you guys so much.
Bye.
Thank you. Bye.
Yeah, that was an awesome presentation. But moving right along, we have a presentation by Zach Moore and Ronnie Scherer from FRC teams 503 and 3542. on adding additive manufacturing to your tool belt?
Hello. All right, so.
Ready. We are all set on my end, Zach, if you're ready.
Awesome. So thanks to everybody putting this together. This is a pretty awesome conference that we have going. I'm glad we could be a part of it, and hopefully we can give you some extra information on how to get you guys started into additive manufacturing. So first we'll start off with a little bit of who we are for you guys, and then what is additive versus subtractive, why should we use it, how does the industry use it, what are some good FRC uses, and then a majority of the presentation will probably be spent in how can we get you guys started, a basic understanding of your slicer settings and how to get you printing successfully in a few different materials, and then some design considerations, some things you want to watch out for, and then we'll finish off with Q&A.
So I'll go ahead and kick it off here. So my name is Ronnie Shear. Did mechanical engineering at Kettering University here in Michigan. Currently, I'm an engineer at Azoth 3D and run our production for the facility. Co-founder of Design Flow with Zach, FRC mentor on 3542 Speed. It's out of Temperance, Michigan. Then 9 years in FRC.
Yep, and I'm Zach, also into Kettering University. I'm finishing up my systems engineering master's and a systems engineering certification through Penn State and MIT. But 3D printing is kind of where we enjoy spending most of our time, so that's where Design Flow came into play. Spent the past 6 years helping mentor an FRC and really enjoying it.
Absolutely. So I want to start off here. What is additive manufacturing? Some people might be aware of stuff that's at home or desktop setting. And then how does it compare to subtractive manufacturing? So I'll put into subtractive manufacturing. It could even be a hand drill. You're using a standard drill bit to take material away from a piece of stock. Maybe it's a piece of 1x1 in FRC type of setting. It could be your CNC router that you use to do belly pans or even do 2x1 tubing for frames. You have lathes that you could use on your shafts. Knee mills, this would go under anything like a Bridgeport, stuff that maybe you're doing a custom hole pattern on, or maybe you have a ProtoTrack. Then a VMC, so anything that maybe you have a Haas mini mill at your school, or somebody's upgraded to any type of vertical machine center that you use there. So I have a picture of subtractive to the right. These were drive rails that we did on Speed, but this would be something that would fall under the subtractive manufacturing category. You have fixture or work holding to hold it down to the table. Then you would have a cutting tool in a holder or a collet that you would use to cut the material away from the billet piece. Under additive manufacturing, almost every form is going to be adding material, whether it's a powder-based, a solid state that came from pellets or liquid resin, or if it's a liquid that's infused with a solid. So some nanoparticle jetting would fall under this category. But the basic concept is that material is added, and it always happens on a build plate. That surface can change, but most of the time, once you print on that build plate, you take that part off. There's no part setup, there's no fixture setup, there's no time that you spent for soft jaws or something for that itself. These can be used in classrooms. So if you have maybe a teacher that oversees your program, or you're a student and you have access to a lab classroom, these can go off of standard 110 outlets, little noise. And once you start your print, there's really not an operator that has to stand by it like sometimes we have to have with subtractive manufacturing. So going over almost all forms of additive, you have material extrusion, plastic, composite, and metal. So plastic would fall under your PLAs, stuff that you see at home. Composite is more of the continuous strand fibers. So there's really two big players, Markforged and Desktop Metal. One does it with solid strand fiberglass and carbon fiber. The other one uses a tape composite. And so they use this with a roller and heat press. And then material extrusion with metal. So this is something like Rapida that kind of uses a two-step process for metal. Powder bed fusion, I stuck multi-jet fusion. That's an HP kind of binder jet process. But you have SLS, which uses a laser with powder nylon, and then DMLS, which is a laser with metal. Then vat polymerization. This is all the liquid resin printing that you would commonly see SLA, clip, DLP, these will all fall under any vat polymerization process where it uses a laser or a light source of some sort with a liquid resin that cures these photopolymers. Binder jetting for metal and sand. So this is going to be a liquid or chemical fuse process that is going to deposit a chemical into a powder metal or powder plastic and have a reaction that fuses those particles together. Then material jetting is kind of a mix where you would infuse particles inside of a liquid that you're doing. This could be really fine details or exotic materials that some companies are doing that these days. So FDM or FFF, this is standardly what you would find at your house. Most common 3D printing, when you open your box, you can print materials like PLA, PETG, TPU, kind of right out of the box most of the time. Composite printing, that's going to be, you hear a lot of teams talking about, they have a mark forged and they reinforce parts with a continuous strand carbon fiber, continuous strand fiberglass. That's going to be the process that they're talking about. Desktop Metal is a kind of a new player in this segment. They use a tape process that is slightly different. It's kind of rolled on in between the parts. The definition isn't quite as good, but it's a new technology in that realm. And then metal printing, you have filament based, which is basically like a spool of PLA, but it's a metal. And then you have a paste based, which is kind of what Rapida does, which is kind of in cartridges, which is a water-based solution, and then rod-based, which is what Desktop Metal uses. And they kind of force those rods with heat through an extruder versus having a continuous strand of filament. The last time under powder bed fusion, so we have a SLS or selective laser sintering. There's a picture of a SLS machine to your right here that I run at my office, and then a DMLS part on the bottom. The powder-based systems are going to run off to the simple concept that you have a vat that keeps your good powder, and then a build platform that, as one rises, the other lowers, and there's a wiper that goes across the platforms that spreads a layer of powder. This can be anywhere from 25 microns up to 200 microns. Very similar to how you would slice a standard print, but instead of the Z height changing to extrude either more or less material, you're just changing how much of the powder that you spread across to then have a laser come over top of and sinter it and form it into your solid part. These have a lot more degrees of freedom as far as the cosmetics of a part. They can be supported a lot better and maintain structural integrity. You can get complex geometries with the DMLS that you can't get in some other fashions of printing. Under vat polymerization, so this is a Nexa 3D printer. It's one of the world's fastest printers. Nexa and Carbon are going back and forth right now. And this is a robot part that is kind of a counter roller that we used this year. This is a part that is done in an hour and 15-minute print time. It's about 7 inches tall, so it's a fairly large part. This is a process that is DLP based, and so it projects that single image. So every slice layer, they do a cross section of the part, and that is what's projected onto the build plate from the resin, and that's how it's able to print so fast. Where SLA is the more traditional, it's been around for a very long time, but it uses a laser tracing or sometimes 2 laser tracers, and they trace the body of the part. But obviously there's a lot more ground to make up when you have a single point laser versus a entire projection. You could think of it like a TV screen that was flashing an image of your part at a certain cross section per print. Binder jetting printing. So this is the most exciting for me. This is a new process that I've been working on myself. These have multiple players in the game. Some plastic is the HP multi-jet fusion. So this is a powder bed fusion method, but it's a binder jet process. This is kind of replacing a lot of SLS machines for new customers who may be adopting it. It's fast. There's also a large build area, and it's not quite as expensive to run compared to some of the traditional SLS. The part quality is extremely good, but part density, which is really important for material characteristics, is a lot higher than what it generally would be. This lends to a larger build blocks, infinite geometries. They have PA6s, PA11s, PA12 nylons, and you have TPUs that are coming out as well. Now they have polypropylenes, which is if you had a deck chair or anything like that, a lot of industrial uses in the polypropylene segment. Now metal printing, this is digital metal, desktop metal, HP, GE, X1. Those are the main players. The only one that really has a unit out in the open is digital metal. That's a machine that we have at Azoff that I run every day. The desktop metal has a couple beta machines out, much larger, slightly different process, but the digital metal machine is what you'll see up in the upper right-hand corner. It's a process that has one gantry that spreads powder, then a second gantry that spreads a binder. Ours is an organic binder. You could think of it like a glue. So we're spreading a powder, then we're gluing it together with a binder. This holds it into what we call a green state. Then after that green state, it still has to go through multiple processes to actually form into a solid metal part. So for your team, why additive manufacturing? So accessibility is better than it ever has been. You can now buy a Energy3, let's say, and you can have a price point of $230. Maybe you upgrade a nozzle, get a roll of filament, and maybe you're a little under $300. But most teams have a budget for new tools or things like that, that maybe they're buying a new drill or a new bandsaw. I'm trying to tell you that you should probably invest in a 3D printer if you don't have one. We'll get into later on of what are the capabilities and why you would want to. But it's a good investment for most teams. There's a lot of teams that have them, and I think the adoption is growing every day. Free machine time. So yes, it still takes time, but there doesn't have to be an operator right next to the printer. If you guys are leaving the shop at 9 o'clock at night, you can start the print or start a series of prints, and those are ready when you get in the morning time. You can kind of not have as much wasted time in your schedule. Exposure for students. So as far as industry, I'm in it every day. So if you're an FRC mentor listening to this right now, or you're a student, you either need to push your coaches to do more additive, or if you're a coach or a mentor on a team, you need to push your students to dive into this technology a little bit more. It's only grown in the industrial segment for prototyping, end use components. Some of the printing processes today, the detail, the part density, and the speed of manufacturing is severely increasing at an alarming rate. And so this is something that anybody should be jumping into right now and kind of getting a hold on the market. Faster partability for FRC teams. So if you need certain parts that it might take 3 days shipping from a supplier, but you can print that same part in 4 hours, this is where that would come into play. And then extremely quick prototypes. If you have 5 to 10 printers, you can prototype an entire mechanism in a day and have a very quick turnaround time, which is in the early seasons, the first couple weeks, this is huge for teams. So how do we in industry use additive manufacturing 3D printing? So we have mold. So the upper left is a mold cavity piece that we use on a urethane. The middle is a work holding that we use for a customer that needs to manage their arbors. The upper right-hand corner is going to be a work holding piece for an assembly jig on a major OEM automotive assembly line. The bottom left is a gripper. So this is for a tier 1 supplier. These are part grippers that go on the end of robots and manipulate parts. And then the bottom middle those are for a medical industry, for medical machines that are in almost every hospital in the US. So these are just some of the markets that we use every day. You can see it goes from end use components to prototype components to tool storage that is on a bench that maybe no one thought of, but that blocked a 3D print. We didn't have a machine setup time for it like you would on a CNC, and we're able to part mark or put ink right into the part to put a logo on it, to put the sizing right on it. That didn't have to be etched in. It doesn't wear away. It's underneath the layers of material. How you can bring this to FRC. So I would recommend that every team start simple. This is going to be simple parts that don't require a lot of support. Maybe it's a pulley, but you take the side flanges off and then you print those on a separate print. This allows you to not have support material. It's faster. You'll have better reliability, a much better surface finish, which can be important. I know that there's quite a few people who will start 3D printing and the parts just don't look quite what they expected. And they might have a lot of support. The density of supports wasn't there. A lot of factors that play into it. You can really increase your adoption rate if you have a really good experience the first time doing it. And that comes to kind of setting yourself up for success. that's a big thing for us and on our teams that that we preach, is doing simple parts first before we get complex. Now the bottom left is a more complex part. This is the SLS part that was on our robot. These are parts that maybe not every team has. Every team doesn't have a $100,000 SLS printer, but there's companies like Formlabs who now have their Fuse One. This is now a sub $20,000 printer all in. And now that's starting to get a lot more affordable for teams to do complex geometries parts. Tool storage and organization around your shop. If you're making assembly fixtures or soft jaws for machining, you want to store these somewhere, or you have a toolbox and you want to have your go-to tools that you need every time. This might be a couple rivets, a couple fasteners, maybe a 3/16, whatever it is. You guys can have it kind of on hand. And then spirit items, I included a full color print that we did at work. This is a small Bowser. It's a fun picture to include, but this could be any giveaways, trophies that you guys do. This particular model is an FDM process, but this printer has inkjets affixed to it, so we can do full color 3D printing. Thought that was something cool to add. So the common materials for FRC, everybody should start out with PLA. I don't care if you have a lot of experience, your team's been doing 3D printing for a while. There's so many uses for PLA, or I'll even throw tough PLA in this that can be used. These are guards that you can see, guards for a swerve module. This can be from getting material, carpet, grease out of the module, kind of shields the gears. Then you have an implant that you use for a wheel. Now, these are just some examples. You have tons of sensor covers, tons of mounts. On our team, I know that we probably did 50% of our parts were a tough PLA. And it was just using some of the techniques that we're going to talk about to properly picking material for these parts and not kind of going way off the board with it. Another one that's commonly used is nylon. So you can see on the right, there's a set of swerve drive modules that have an entire nylon base, and there's pulleys that were dyed green. Some of the benefits of the nylon is that after the SLS process, you can dye these the white powder to the color you want. But these are custom pulleys, custom end caps, and custom swerve encoder gears. These are things that, although these are SLS, they also make an FDM nylon. Or carbon infused nylons that we'll get to on the next slide, which falls under embedded materials. So these are super common. Lots of teams are kind of adopting the Markforged machines, but there's other materials. We've been doing some work at Design Flow to release this summer for kind of a setup for teams that maybe have Ender printers or other artillery printers, maybe don't have quite the budget. How do we print good parts that maybe I'll say look like and function like a Markforged part, or a nylon with chopped carbon fiber inside of it. So if you look here, we have 3 examples. 2 of them are Markforged, and one is a carbon PETG that we did. That's on the right. Markforged is in the middle, and then a swerve drive module is on the left. This is an early prototype they did. Now I want to focus on the middle here, because I think there's a common misconception that everything has to be just additive or just subtractive. This is a really good example that we use for a custom pulley application on my team, 3542. This is where we kind of call it a hybrid part. We mixed a little bit of additive and a little bit of our CNC subtractive capabilities to come up with custom pulleys. This was for a 4-bar lift for climbing. This was 2019. Sorry. Everything doesn't have to be just by itself. There's lots of applications that it could be a completely aluminum 6061 machine gearbox, but maybe your spacers, your end plate, or your end cap could be a 3D printed part. They don't have to be just one by themselves. These definitely can be parts that coexist next to each other in assemblies.
So a lot of the machines that Ronnie's talked about earlier in this presentation are industry level or really high quality, expensive machinery that big companies like Ford would run out or something like that. But what we're trying to emphasize here and what we're getting into is that to achieve the same results as you saw earlier in the past couple slides, you don't need to go spend $3,000, $3,500, 15 grand on a 3D printer, specifically for PLA, PETG, nylon, or carbon fiber embedded nylon. A lot of these printers that you see here is like under $500. The Artillery Genius is actually a new printer that's actually pretty good. I have 3 of them running almost next to me right now. They're easy to start. They have a volcano nozzle. There's pretty hands-free in terms of maintenance, and they produce excellent result for PLA or PETG. And then the Ender 3 below that one on the left is a pretty common printer. I think it's like the #1 used printer right now for the United States. It has a huge user following, so there's lots of aftermarket prints for it to upgrade it. It works great out of the box, and a lot of people that I know are using this for FRC parts. And then you have some big players that outside of the Mark Forge are on the right here. The Prusa is a really good printer that's almost perfect out of the box for printing a lot of the FRC parts. And then the Ender 5 Plus below that. The other 3 printers in this diagram are about an 8.5-inch build volume, but the Ender 5 Plus is a 13-inch, and that really increases your capabilities. So for nylon or embedded materials, the printers on the left here are pretty end use, ready to go for if you wanted to just load in carbon fiber or embedded material or nylon or something like that. Very easy, free of use. But again, the price tags are $5,500 for the top Ultimaker or $2,500 for the TAS below it. There's actually a company called Micro Swiss that's based here in the US that makes all metal hot ends or wear resistant nozzles, those kind of things, to be able to upgrade those lower end printers easily. They're direct swap-ins to be able to then use nylon or embedded materials. So this could easily be a stepping stone in for teams. If you're a low budget team and you only have $200, $300 to spend, it's very easy to get an Ender 3 or an Artillery Genius or something along those lines and start printing PLA right away and start seeing improvements. And then in a year or two, making those upgrades. And then once you understand how to print and how to print quality end use parts, investing in your machines and then printing nylon or embedded materials. The second piece outside of the hardware is going to be software. You're going to need a slicer that's able to convert the 3D model that you put in into G-code. Ultimaker, Cura, and Prusa Slicer are very user-friendly. They have different modes inside them for easy use or advanced users. They support multiple different materials. They do automatic slicing for you based off of pre-configured slicer settings. And then Simplify 3D is a pretty common, widely used slicer program, but it is a cost basis. I think it's discounted for students, probably for education discounts and things like that. But you will need one of these softwares to download, and they're very easy to work with. So on top of those 2 things, you're going to need some kind of basic knowledge on what you're doing within the slicer. So we'll run through a couple of quick settings that you'll probably touch or play with to try and get quality end use parts out of your prints, regardless of the material. So the first one will be infill density. That's just basically the amount of material inside the part, inside the walls. So in the pictures below, you'll see like the cross hatching or the triangles, that's your infill. You can fill the part as much as you want, but you start to see diminishing strength returns versus part weight or material usage right around like the 50% mark. As you can see, like the 10 to 30%, that's a very drastic improvement, and it's even pretty noticeable from the 30 to 50%. But from the 50 to 90% there's not a whole lot that you gain in terms of strength or lattice, but you will increase part cost and weight. So then there's different types of infill. This is just a basic kind of run through. There's grid or rectangular, which is the most common, probably the default setting in your slicer. It's the fastest because the nozzle only has to track in sweeps in one direction. It's very low complexity. It doesn't necessarily offer the best strength though. The triangular normally is an easy swap. It does offer quite a bit of strength in different directions of part loads. It's most strong if it's perpendicular into the Z direction, which means the direction that you're printing in. Then there's cubic subdivision. This is actually a 3-dimensional infill. It prints basically little pyramids inside the part, moves them around a whole lot. It is a drastically slower print compared to the two above it, but it is stronger in all directions comparatively to triangular, which is only stronger perpendicularly. And then concentric. Concentric is really used for flexible filaments. It maintains the flexibility of the material after the part is finished printing. So then for layer height, what layer height is a 3D printer works by extruding material onto a build plate layer by layer. So the layer height is the thickness of that layer. It's normally measured in microns, which is 0.001 millimeters. Typical layer height is 115 or 1 millimeter, or 100 micron, 150 micron, or 200 micron. Sorry, that's what I meant. Which is 0.1, 0.15, or 0.2 millimeter. And this is kind of where your trade-off starts to begin in print finish and your speed and the functionality of the part. This chart provided kind of shows that if you want a really strong part, hit 100% infill. And then if you want, everything, probably about a 70% infill and a 0.2 millimeter layer height. Then your line width. Not a lot of people normally mess with line width, but this is actually something that can probably help you out. The line width is the width of the line that a single extrusion passes by, like how wide the line is as the plastic flows out of the nozzle onto the build plate. It's a function of the nozzle size. So normally you have a 0.4 millimeter nozzle. That could be a 0.6 or 0.25, anything like that. But normally it's a percentage value of what that nozzle size is. As shown in this chart here, 140% of nozzle size is pretty optimal for strength of part, but it does tend to decrease the quality of surface finish of the end use part. But it is one of the better ways to increase strength in a part other than infill. So not a lot of people use this, but it's the key to try and get stronger parts. Another thing is wall thickness. So before the infill starts, the 3D printer will run a wall around the outside portion of your part. It can be however thick, however many layers deep that you want it to be. But normally this is another parameter included with the line width that will increase the part strength greater than increasing infill will, or you'll see more value for weight or material usage out of increasing those two parameters than infill. So like shown, 100% infill with a 2 perimeter is not very strong comparatively to 133% line width with 3 perimeters, or 100% line width with 4 perimeters, or 200% with 2 perimeters. So if you only run 2 perimeter lines, but you do it at 200% line width, it's significantly stronger than 100%. So it's just something to use. Then print speed. Print speed is directly related to your finish quality, how fast you print the part. It's the movement speed of the print head. Normally for PLA, you can run anywhere between 30 and 70 millimeters per second. It's pretty forgiving when it prints. But for things like nylon or PETG, things like that, you normally want to stick around the 30 to 40 millimeter per second range. The graphic kind of shows you like what'll happen when you start creeping up on those boundaries. It will drastically increase or decrease your production time, so you'll get a part faster off. Could be useful for like if you want to just physically see something in your hand instead of CAD and you're not actually going to use it. But you'll generally want to stay in the regions we'll show you in a minute. And retraction. Retraction speed is how fast the filament is pulled back through the hot end. And then travel is how far it's pulled back to the hot end. So these settings deal with the stringiness of the material, the plastic, as you see on the right versus the left. And tuning these can help you reduce that stringiness or get a better surface quality or anything on your parts. Normally you want to stay between 0.5 millimeters and 3 millimeters on your retraction distance. And it's normally roughly around the same speed or half the speed of your print speed. And support material. Anything with overhangs that are greater than 45 degrees will want to print with support material. As you can see in the T. Support material is helpful for getting a stronger part with overhangs, but if you can design for 3D printing and try and minimize those overhangs, you'll have a higher quality part. The denser the supports you use, the harder they're going to be to remove, but the more quality of layers you'll have on top of those supports. But the lower the density, the lower material you waste per print, and the easier you're able to get them off. 30% and 45%, or 30 degree and 45 degree overhangs are normally good to stick around with. 60 degrees, the slicer is going to start putting support material in. And then bed adhesion. There's a lot of different materials you can print with, and they all adhere to the bed differently. This may, and based on your part geometry, it may require you to have some kind of extra bed adhesion property, like a raft. A raft is good for really, really small cross-sectional parts when you're printing, because you want them to stick to the print bed throughout the whole duration of the print. A skirt will help eliminate the oozing or the little bits of plastic that come out of the nozzle when you first initially start a print. It can help you get a solid first layer for your print and get you a good foundation to start on. And then a brim is kind of like a raft, but it's directly attached to the part. So you'll have to peel it off, kind of like support material after, but it will help adhere that part to the bed for the duration of the print. So if you have like a really tall spacer or something like that, but it's, you know, only ½ inch diameter, it might be useful to include a brim on the print so that it doesn't fail 7 hours into your whatever tall spacer you're printing, and then just peel it off at the end. So a couple good starting points for prints. PLA is extremely forgiving with 3D printing. It normally adheres to whatever you put on the build surface, but what's pretty good to start with is glass. Most 3D printers now have an ultra base type of bed, and which is like a perforated glass material, which is very good out of the box for printing PLA. Most materials manufacturers will provide you a recommended temperature setting for their material. PLA is normally somewhere from 190 to 220. The bed temperature is normally 45 to 60, somewhere in that range. And like I said before, you can print up to 70 millimeters per second with this, and the retraction distance of about 0.5 to 1 millimeters. It's very good when you first get a material to run what's called a temperature tower. So a temperature tower is something that you put in your slicer settings where it changes the temperature of the hot end nozzle from a certain temperature to the end temperature throughout, like at different layers during the print. So you'll start printing this tower at like 190 degrees C and then increment by 5 degrees C every 20 or 30 layers. It takes about an hour to print, but then once it's done, you can see what that material provides the best surface quality finish at. So it might be that one material that you get, or one spool material is like really good at 195, but another one requires 210 to print. It's just something easy to check to start with. Another common material is PETG. We haven't quite talked about it a whole lot in this presentation. The deal with PETG is it's cheaper than nylon and more durable than PLA, but it's really stringy. It's kind of more difficult to print with. That being said, you can produce some pretty good parts out of this material if you have some experience with doing it and you do some trial and error and testing your retraction settings and your print speeds. Normally for this material, you want to be around the 230 to 250 degrees C range with a bed temp much higher of 75 and 90 degrees. This is one of those finicky materials where it doesn't really like glass. It likes to be on glue stick or painter's tape, which normally means you can take like an Elmer's PVA glue stick and just run it across your build plate, 1 or 2 quick layers of that, and it won't peel up on you. Print speed is normally about 45 is I think what we stick to for millimeters per second. And your retraction has got to be a lot bigger than PLA because of the stringiness of the material. If you're running a direct drive setup instead of a Bowden setup, which a direct drive just means the extruder is directly on the hot end, and a Bowden is where you see the tube that comes off the hot end over to the side of the printer, where the extruder is located. Direct drive normally has to be lower in retraction rates. So nylon is one of those complex materials that's kind of harder to print. You want to have an all metal hot end kit. You want to have some kind of material as your nozzle that's not going to wear easy. Something like steel, hardened steel is what we use, A2 hardened steel or tool steel, with an extruder temp of anywhere up to 265. I think most of them run in like the 250 degrees C range. The bed temp is normally likes to be closer to 90 than 70. And you really want to have a Garolite or PE build surface for this. Garolite is what we would recommend. It has a beautiful surface finish on the bottom of the part, and it adheres really, really nicely to it. We print all of our nylon at around 30 to 35 millimeters per second. It seems slow, but it's worth it in the end. You get a really good finished part. And then your retraction distance is relatively the same as PETG. So for embedded materials, on the left is the nylon and on the right is the PETG. Most of them are pretty similar to their non-embedded counterparts. You're going to want to have the same type of settings. The only difference is like with the PETG embedded, you're going to want to run even slower than you would run normal PETG. And for both of these materials, because there are chopped bits of carbon or glass or something embedded in the material, it helps to have a larger nozzle size. So that 0.6 millimeter nozzle size is going to help you out a lot. And then a little bit of design considerations when we're rolling through this. So layer orientation is important to the strength of your part. So the bonding between the layers is the weakness in a 3D print. So if you apply tension against that bonding of the layers, that's where your part is weak. But if you apply tension where the part is pulling against fibers of plastic, not the adhesion between the layers, then you have a strong part. The opposite is true for impact. If you impact a 3D print along those layer lines, it'll probably shear along the layer lines. But if you impact it down in the Z direction, it's a pretty strong part. And the top face generally has the best surface finish. You can tune the sides to come out very well with your layer height and your print speed. But it's just something to note when you're putting something on your print bed and your slicer, that you'll want to lay it flat to try and minimize supports, but then the top layer is probably what's going to look the best in the end of the day. Then infill and wall thickness. So increasing your infill does increase strength, but it also increases your weight. So the orange line showed here is with just increasing wall thickness, and the blue line is just increasing infill. So as you can see, the strength of your part versus your weight for different set points is significant. This was done in tensile testing, so your results might be slightly different during impact or some kind of fatigue test. But this is normally what we base our prints off of. If you need strength in a part, our infill is normally around 40 to 55%, but we increase the wall thickness or your line width to get the strength out of the part without using all the material. Stress risers. So fillets and chamfers help out a lot when you're designing. A print head can move on a constant speed when it's doing a fillet on the XY plane versus a sharp edge. This helps the layers adhere better when the print head's not jolting around all the time. And when you have a stress concentration on a layer line, it produces a very weak print. We found this out in some of our swerve forks and had to redesign them to try and include large fillets or combine them with sandwiching them with bolts, sandwiching the layers with bolts, and things like that. So it's important to understand that when you're designing parts that are meant to be printed, you should try and eliminate any direct corners or try and mesh those corners nicer. And then shrinkage. So when the plastic transitions from a liquid state to a solid state, the part will shrink. Now, most of the time that's negligible, but it is something to consider if you're doing a part that has to be super precise. Nylon has got the greatest shrink rate. That beat, it's only 1.5%, but it is something to consider when you're printing like something that is going to be tapped or have a threaded insert put into it, or something that's for a dowel, something that's supposed to be tight tolerance. it's nice to have that designed in when you begin and not have to be drilling out your 3D prints or something like that at the end use. Most of the time, PLA and PETG will be pretty close, true to form, so you don't necessarily have to do those types of things to them. And then working with inserts. So there's very few circumstances where we intend to directly tap the plastic of a 3D print. It's not necessarily the strongest way to be able to do that because you are dealing with those layers again. So if you shear that bolt right out, you probably ruin your 3D print. So the way that we normally deal with something that has to be tapped is with a threaded insert. Those come in two different types. Of course, both of them are sold by McMaster. So there are screw to expand inserts and then tapered heat set inserts. Both of them need designs a little bit differently. The screw to expand inserts are just a straight hole through your design. And then when you screw the bolt or the screw into it, the knurling expands and embeds itself into the plastic of the part. And it becomes very hard to rip that thread out of the plastic. For a heat set insert, there's normally a taper in the hole, and you push the insert against the taper, and then you use a soldering iron to melt the insert into the printed part. So this will, there's tips and tricks, like if you throw a insert the opposite direction than what you think it would work in your mind, it actually pulls against the taper when you bolt it down and creates a stronger joint. That's something that Markforged advertises, and it does create a stronger parts. So I think that's about all that we have for this presentation. We're about 15 minutes out of our time, so we'd like to save that for Q&A. If there are any questions in the chat or anything like that. Hopefully we're able to ease your problems with 3D printing and get you guys going. Feel free to contact either of us as well through the 503 website or through Speed or through Design Flow or through any of these areas. Chief Delphi, we'd be glad to help you guys out if you have any problems at any point.
All righty. Thank you guys so much for that interesting presentation. We do have a couple of questions from the chat. I will just go ahead and pull that up. The first one is, how much is additive manufacturing used in FRC today, and where do you see that going within, the next 5 years?
So I guess I'll start on this one. I can't speak for every team, but what I can do is I can speak for teams that I mentor on directly, and then people that I talk to are other mentors in the industry that we help, and other teams that my work sponsors. So for us on Speed, I would say that of our robot complete assemblies, I would say upwards of 40 to 45% of our robot was printed components. This year is probably the most extreme. We're a team that's fortunate enough to have a CNC in-house and other manufacturing abilities, but 3D printing has really helped us to make our robots lighter overall, in kind of new geometries, and then also changed densities on pulleys and in gears and things like that. We did shooter hoods, things that are, I guess, generally harder to machine or take a little bit more personnel or individual time. We transferred those over to additive manufacturing. We don't have a huge team, so if you don't have a huge team, but maybe you have resources to buy printers, it's a really good way to free up resources, a human resource, to maybe better use on your CNC side or subtractive side. Programming, there's lots of facets to first and kind of offload some of those tasks onto a 3D printer. I think this number is going to continually grow. There's more and more teams posting questions on Chief, reaching out to us, asking for help printing certain materials. I would say by 2023, I would say that almost every team has one, and maybe we'll get to the point where a major manufacturer comes on board and donates Creality printers, or at least vouchers to go buy printers as a team.
Awesome.
Pretty similar on our, it's pretty similar on our side as well. We have a large team on the opposite end, and we feel like additive manufacturing has definitely helped us in the prototype phase. We've been making scale models, quick prototypes, different things for our shooter. I mean, we had full gearboxes built like day 3 this year for our shooter with hood and different capabilities on it, which was awesome. Like our team has never seen that before, and it became prominent when we started experimenting with this stuff in the off season.
Awesome. Obviously, you guys mentioned a couple of different materials. What type of 3D printer do you recommend for maybe PLA versus TPU?
So for TPU, you're going to want a direct drive more than PLA. Pretty much any printer that you get, you'll be able to run PLA pretty well on. It's just going to be your ease of use. TPU is kind of finicky. You want something with a higher flow rate, and you want something that's able to retract the material without it going through a Bowden tube. So you're really going to want to look for a direct drive product. So if you're in the $1,000 range or less, then the Prusa is a really good printer for it. Or if you're in the $500 range, then the Artillery Genius is a direct drive printer. If you have an Ender product now or a Creality product now, then there are kits out there that'll get you a direct drive. We don't normally cover TPU because it's not a widely used material in FRC. There's some talk about teams wanting to use it to make their own timing belts, and it just doesn't really hold up to the standard of the competition. So
yeah, I can attest to that one. Then just as far as price point, if you have a little bit more money to spend, and like Zach was talking about, the easeability, sometimes you get mesh bed leveling, or companies are using BL Touch or other sensors for better bed leveling. And so sometimes that's a big deal for a team that they want to just be able to kind of more so click a button and then start a print. And other teams kind of want to have the aspect of they want to upgrade it. They want to have the ability to kind of add things onto their printer and more tailor it to their team's needs. This is where sometimes it's nice to have an FRC team that maybe has a couple of each. Maybe they're workhorse, or they start out with something like they have an Ultimaker donated, or they have a Taz, a Prusa, other printers out there on the market. And then maybe they get into, they're like, want to do more polymer printing, don't want to invest $4,000 now into a Mark I. They look at something like a Creality, and then do a direct drive and all metal hot end from Micro Swiss, and then change their bed material or adhere a Garolite surface to that. And those are pretty sound out of the box with upgrades on them to be able to print those materials. For just speaking, we're going to be releasing to the public on Chief later this summer. We've been doing quite a lot of experimenting and tons of testing and printing with carbon filled materials. And so we're going to release some settings and some recommendations, printer and such. So look out for that this summer for your team to be able to kind of read the PDF and have a little bit better idea of what you can print with. The whole goal of it has been to as little resources as possible, with the best parts. Our benchmark have been Mark Forge parts. We each have Mark Forges, and we print on them daily as well. So we know the quality and where we use those parts. So that's been the benchmark for teams that don't have a Mark Forge, or they can't get 5 Mark Forges. So they need to be able to have that solution on other lower end printers to be able to print similar quality parts.
So I guess you also tied it to actually another question we got, which was, would you recommend a fleet of cheaper printers like Ender 3s, or maybe like a lower amount, like 1 or 2 of maybe more high-end printers like Mark Forges, like you mentioned?
Yeah, so the deal with a cheaper printer is you want to understand what's going on with the printer. The reason that the Markforged price tag is so high is it's a complete end use thing. You just press a button and you go, and you get a high quality part at the end of the day. If you're willing to invest the time into it for significantly lower money, you can get high quality results off of a lower end printer. But in terms of printing, the print time is kind of the choke point of a lot of production. So having more is always what I kind of like to lean towards. So if I'm going to buy a Mark Forge at this point, I'm probably not, and I'm probably going to go use that same money and buy 4 or 5 lower ones, because I can run, 5 times the parts on that than I can on a Mark Forge.
Yeah, I would go similar with Zach on this point. I said earlier in the presentation, I'm a huge proponent that I do think that teams are, now that we're getting Mark Forges, our team is fell victim to this, is that the Mark Forge is so nice and they look so good that we just use it for everything. We're lucky enough to have access to multiple of them, but a lot of teams aren't. And they can quickly be overloaded with parts. I've heard many stories of teams, high-level teams, that have overbooked their printers by hours and hours on Mark Forges. So this is definitely an issue. But quick prototype parts don't need to be Mark Forges. When you're doing the first 4 weeks, Onyx is not cheap. $200 a roll, I think 180 is educational pricing. It's not something that's super cheap to just blow through. And then plus you have a print speed of 25 to 35 millimeters per second versus running PLA at upwards of 70 for quick prototypes. Is not the answer that person probably wants to hear, but you need both. So my perfect solution would be to have one Mark Forge that you use for your end use components and stuff that goes on the robot, that you can space those out over a little bit more time. But I would not be scared to have a fleet of 5 to 10 Delta Minis or Ender 3s that run pulleys in low load applications, tons of prototype parts. There's so much area for use of tough PLA, PTG. That I don't think every team needs a Mark Forge. It's nice to have, and I think there's a lot online that says, "Hey, go buy a Mark Forge," but I like them, but it's not, every team doesn't need to buy one. I don't think right off the bat. And materials are getting better, to the fact that, and printers are getting better at the price point that you can get a printer that prints almost all materials or within a couple $100 of upgrades, to be able to print these materials and not have to spend $4,000. So.
So obviously 3D printing is very versatile, and so a lot of cool things can be made from it. So a question we got was, what was the coolest thing, or like the thing that you made that you like the most, or like the favorite thing that you made, or like a part, or maybe like an entire thing, I guess.
Yeah, yep. I think probably Zach's gonna grab
I'm not
something.
sitting here. Yeah, so we actually went through the process on Frog Force of overmolding silicone and urethane onto 3D printed parts. So one of the wheels that we showed earlier in the presentation is actually a PLA hub that we overmolded silicone onto for an intake wheel, because we thought that silicone gripped the totes better. And we didn't have the money to go out and buy a super expensive Fairlane wheel. So we ended up buying the stuff for like 30 or 40 bucks off of Amazon to mix our own silicone. And then we printed a hub for maybe, $1 of material cost, and then overmolded the silicone onto it. And that was probably the coolest thing that I've seen on a robot. Outside of being on a robot, we ran a lot of swerve stuff where we saw, mainly because Strikeforce was doing it, we thought it was super cool, is they were overmolding their wheels, which were Mark Forged. So we did a lot of like Mark Forge stuff with tread patterns, and then we would print a tread pattern in PLA and then do a mold of it and then cast that tread pattern in urethane with a key in it so that we could attach it to a Mark Forge part. And that kind of stuff I get really geeky about, outside of like rack and pinions and stuff like that.
Yep. So for us, I have two parts to it. These will be my industrial examples. Oh man, it's not going to show up very well. I don't. Maybe that shows up better. So this is a metal part. These are just cool models that I've done at work or in the office. These are for a game board piece out of 316L. And then these are kind of just a fidget cube, but it's full color 3D printing, so I'm able to put logos and things like that on it. Now for a robot, this year we kind of did our entire shooter assembly, turret pieces, large turret gear. We had our meter wheel. We were able to do kind of custom, similar to this concept, is that we're able to combine different pitches and different profiles and sizing of pulleys onto an assembly. So we cut our part count down by like 32 parts by redesigning, all for additive. Originally we were like, oh, this definitely is going to have a lot of load on it, a lot of power on it. We probably don't want to do this additive. It's an important part of the game. And so we ended up kind of switching that philosophy and ended up saving weight in about 20 some pieces by switching over to an additive concept. So that's the coolest part for me, is simplifying mechanisms, combining assemblies that too hard for us to machine or not economical for us to machine in-house, over to a machine that has a little bit more control over infinite geometries.
Well, I think that is yeah, that is it from our online chat section. Thank you guys so much for that very interesting presentation. It's very cool what you showed us, and yeah, have a nice rest of y'all's day.
Absolutely, you guys too. Thanks everyone for
Thank you
tuning
for
in.
having us.
All right, so our next presenters are Aroe, Mason, Jake, and Anna from FRC team 2468 on SACOT, the power of STEM advocacy. I think that's how you say it.
Hello, everyone. My name is Arohi, and I'm a rising 11th grader at Westlake High School in Austin, Texas. I am on First Robotics Competition Team 2468, and I'm the president of SACOT, or the STEM Advocacy Conference of Texas. Today, I'm joined by my co-lead Mason.
Hi, everyone. As Arohi said, I'm Mason. I'm a rising 10th grader at Westlake High School in Austin, Texas. I'm a part of First Robotics Competition Team 2687, and I'm the vice president of SACOT.
Today, we are here to tell you about one of FRC 2468's outreach initiatives, the STEM Advocacy Conference of Texas, or SACOT for short. We will share our past events and experiences since SACOT's inception in 2016, and what you, as members of your community, can do to advocate and make a difference.
We'd like to start with this video that briefly introduces and explains SACOT's mission and what we've done to advocate and educate members of not only our community, but our nation as a whole.
The STEM Advocacy Conference of Texas was founded 5 years ago by FRC 2468 Team Appreciate. SACOT's mission is to give all high school students in Texas a voice in their STEM education. We have organized over 1,000 first students from across our state to train them on advocacy techniques, assemble policy platforms, to develop an advocacy plan, and to lobby our legislators for the changes we want to see. SACOT has had numerous successes. Our advocacy efforts have contributed to the classroom connectivity issue and to an increase in career and technical education funding. So, how did we generate this success?
In 2015 and 2016, we attended the NAC conferences in hopes of starting a state advocacy group. We gained the political experience to start SACOT.
In Texas, legislative sessions take place every 2 years. Before each, the SACOT Executive Committee assembles our platform recommendations. We research bills proposed to the Texas Congress, look at platforms assembled by other interest groups, and reach out to lawmakers and other policy experts. The Executive Committee then takes all that we learned and selects a few policies that we believe are best aligned with the SACOT mission and that we will be able to successfully promote. Here's an example clip of the kind of video promotions of our platforms that we will send to help teams understand what we are lobbying.
HB 341, authored by Philip Cortez, is the first of our 3 planks. This bill, which relates to the public funding of career and technology education courses, currently, school districts receive weighted funding for each student they have enrolled in a career and technology education course, which includes classes like computer science, engineering, virtual business, and more. This weighted funding only applies to high schoolers, though. If HB 341 passes, this funding will extend to middle schoolers as well. 8th graders enrolled in such courses will give their school districts more money to further buy materials and resources to fund those classes. Middle school STEM engagement is crucial to the continuation of tech-based education and is reason enough to vote for HB 341.
This process takes a lot of effort, as thousands of education bills are proposed to Texas legislators each session.
The SACOT Executive Committee then organizes our annual conferences, inviting all of our members to join us. At each, we discuss policy and develop our advocacy action plan. In these conferences, we train our members on how to best advocate for our platform. During a legislative session, we meet with state lawmakers advocating for said platform.
I hope they'll understand that high schoolers are really invested in their own education and they want to make a difference in the world. We're hoping that they'll see that and they'll start to listen more to us. We'll build a bigger voice and they'll start to actually spread STEM and put it into legislation that they want certain courses to be in every school across the nation.
I'm sure seeing a group of high school students taking time out of their schedules and having like the courage to go and talk to legislators is just really impressive, and I think they will definitely hear more and want to hear more of what we have to say.
Our first conference is called the Founders Conference. This assembly was strategically planned to increase membership and start SACOT with some momentum. 10 first teams attended, and we recruited 250 new members shortly thereafter. We invited keynote speakers to this event, such as Ray Almgren, the former chairman of First in Texas, John Howard, director of government affairs and public policy at Dell, Evan Smith, CEO of Texas Tribune, and Texas State Representatives Donna Howard and Paul Workman.
SACOT recruits new members using our website, developed by members of our team. The SACOT website allows students and teams to register with the organization and get updates about upcoming events. The website also hosts other resources, such as a database that allows students to easily identify their representatives and senators. Each member has an individualized dashboard, allowing them to take polls regarding STEM and FIRST. We have used polls as a means of finalizing our platform as well. With each poll a user takes, they acquire SACOT points. SACOT points are totaled based on the individual and team with the most points, and we give out prizes to the winners at our conferences. Ways to earn points include polls, adopting teams, participating in events, and more. Adopting a team is when an individual finds another team that's not part of SACOT and helps them join the organization.
Another method of recruitment is at our competitions. With the inclusion of our SACOT booth, teams can familiarize themselves with our organization and learn how to join. We have team members register as they express interest so we can quickly relay information to them. We have SACOT booths at as many competitions as we can. We go out of our way to talk to as many teams in the pits and stands in hopes of recruitment to state advocacy. We even try and visit FTC competitions as well. We also extend an invite to our local legislators to attend the event. This gives them a sense of what FIRST entails and helps highlight why STEM education is so vital.
I see SACOT as one of the key mechanisms in which we can have teams, FIRST teams, educating their state legislatures on what a great benefit a FIRST program is to the community and to the students that participate.
More recently, we hosted the SACOT Gone Virtual Conference, allowing our members to either attend in person or online. To do so, we innovated a technical system combining Skype and Twitch. Because of this virtual model, over 50 FIRST teams were able to attend. Together, we discussed our platform for that legislative session. Our members brainstormed potential policy points to advocate for, including increased STEM class funding and the improvement of technology-related educational standards.
A few months later, we organized SACOT on the Hill, where our members went to the Texas Capitol to meet with and advocate to state legislators. In total, the 60 members in attendance met with 30 lawmakers. By the end of the day, we had spread awareness for FIRST and gained some political momentum. One of the bills we were supporting, HB 341, was designed to increase funding for career and technical education courses in public middle schools. The day after our conference, the bill was moved to the Education Committee. We like to think we were the reason for that. Eventually, HB 341 was incorporated into a larger bill that was passed.
Last November, we organized a new type of conference called the SACOT Summit. Rather than directly advocating to legislators, we sought to open a dialogue between high school students and policymakers. To do so, we organized a panel of speakers including a state representative, a tech CEO, a FIRST in Texas board member, and a STEM policy expert. They answered questions from the audience of 75 FIRST students.
As it says in our name, SACOT focuses its political efforts in our home state of Texas. But we want all students to have the same opportunity to advocate for STEM. So we host conferences like these, like the first SAS. More directly, we have developed SACOT in a Box, where we directly help other teams start their advocacy efforts. We walk them through our state advocacy guide. We have worked with 2 other FRC teams to successfully establish student advocacy groups in Pennsylvania and Arizona. We help them by sharing our development model and by mentoring them via telephone and Discord calls. One of them is actually participating in this event. We also partnered with a low-income after-school program to provide kids with the opportunity to get hands-on experience with STEM. Using 2468's Roblox kit, students have the chance to design, program, and drive a robot as they learn technical aspects of STEM.
Finally, we'd like to share some tips to help other current and prospective advocacy groups achieve success. Number 1, be patient. Political change doesn't happen in a day. Progress is the result of sustained advocacy. Identify the policy points you want to see get adopted and dedicate yourselves to them.
Number 2, do your research. Professional lobbyists usually know more about the bills they're advocating for than the lawmakers who wrote them. Of course, as students, it's unreasonable to hold ourselves to the same standard, but that doesn't mean we shouldn't support legislation we haven't done our homework on.
Number 3, make friends everywhere you go. It is incredibly helpful to know people knowledgeable about STEM policy. For any advocacy group, it is crucial to make and sustain these relationships.
Number 4, work with other teams. SACOT's greatest successes have all been the result of collective action. By working together, FIRST teams in Texas have been able to contribute to significant change in the STEM education system. Without our partners, none of what we do would be possible.
Since SACOT's start in 2016, we've met with 83 legislators, gained a following of over 1,000 members and 146 first teams, helped enact 2 policies, and hosted 6 conferences. We welcome the opportunity to mentor new teams. If you are interested, please reach out through our social media platforms at FRC2468 or at SACOT Texas.
We hope y'all enjoyed that intro video. As our motto says, SACOT's big goal is giving Texas high school students a voice in their STEM education. But what does this mean? The first thing it means is that you, as a high school student, have a voice and an opinion about how STEM education should be done. You have lived it. You have seen the good things and the more difficult things. You should make that voice heard. But closely tied to that first thing is that your voice by itself may get drowned out. But if we all have the same voice, together we can make it loud.
So SACOT is about making it loud for high school STEM students in Texas. But what do we care about? What are the goals of SACOT? And what do we do with our louder voice? The first goal of SACOT is to increase spending on STEM within the state of Texas. We're all very passionate about STEM, and we're good examples of why STEM spending is important. By directly communicating with our legislators, they can hear firsthand on what we think is important. Our generation is the one that is driving the future, so it's important that we proudly use our voice to speak up. The second goal of SACOT is to educate our government leaders about the issues of STEM and in particular robotics. It's important to see how many of our leaders, well, it's amazing too, how many of our leaders aren't well informed on what STEM means or how it impacts us as students.
So that's what SACOT is all about, and it's going great so far. Let's take a look at the last few years in detail so you can better understand how SACOT was started.
So FRC 2468 attended the National Advocacy Conference, also known as NAC, from 2013 to 2015. NAC takes place in Washington, D.C. each June, and at this conference, students get the opportunity to talk to members of Congress and advocate to expand first to underrepresented populations while promoting STEM education. This event provides a hands-on and practical introduction on what you need to be an effective advocate at the local, state, and federal level. We loved the experience and returned every year up until 2015. However, we learned that direct legislative change is often made at the state level rather than the federal level. So we decided to create SACOT, a STEM advocacy conference that is specifically focused on advocating for legislative change at the state level here in Texas.
In 2016, SACOT held its first ever conference, the Founders Conference. We began to integrate founding FRC and FTC teams into SACOT to help start the organization with first robotics teams from all around Texas. We already started to see a large increase in membership, with over 225 new members joining that October through our inaugural conference. We established 3 main goals that we wanted to see take place at each annual conference. Our first goal is to teach members how to advocate. Most students haven't had the opportunity to formulate convincing arguments for a given cause. It really can be nerve-wracking to talk to congressmen and women. And so at each conference, we provide training and role-playing practice for advocating before we go and execute. The second goal is to collectively discuss and decide upon things we feel passionate about, so we as a group can advocate for those things. We do this by some various methods, such as breakout sessions, online group forums, bringing in outside parties to speak and give a unique professional perspective to what they see going on at their level, hosting panels with speakers from all sorts of unique backgrounds, and more. The third and final main goal we have for our SACOT conferences is to have face-to-face meetings with legislators. We help organize and coordinate these meetings so things run smoothly. Even though our annual conference does not coincide with the legislative session that happens every other year here in Texas, we still continue to have meetings with legislators.
In January of 2017, we began our second push for members with our first annual conference at the Texas State Capitol. We began building our SACOT community through this 3-day conference where we held panel discussions with Texas representatives and first board members, along with discussions about 3 major problems we saw in our state at the time: a lack of STEM jobs, a lack of STEM educators, and a lack of STEM in our communities. At the beginning of each conference, students collectively brainstormed and decided on what platform we wanted to do for that conference. Like Arohi mentioned earlier, our annual conferences coincide with the Texas legislative session every 2 years. The main purpose of our first conference was to teach members and train them on how to advocate and help them understand the process of how to interact with legislators and then to go advocate. We had small groups meet with over 50 legislators to advocate for the SACOT bill of that year. It was HB 395. And educate them about UIL robotics, the funding that it provides, and to inform them about SACOT, plus the importance of STEM. Overall, it was a very successful first annual conference with a large increase in membership as well.
In December of 2018, we held the SACOT Gone virtual conference. This conference was the first time that we connected our audience, not only in person, but virtually through notes set up for this live stream in Houston, Austin, San Antonio, and a speaker live from New Hampshire. These notes helped our training and discussions reach teams in not only our immediate area, but throughout the entire state of Texas and beyond. Our platform at this conference consisted of discussions about how there was a lack of STEM education, not only in Texas, but across the US, and what we could do to improve funding. Many important figures like Texas Representative Donna Howard, Caroline Joyner from Amazon, the former president of FIRST, Don Bossy, and more tuned in to speak and share their advice and knowledge. We held discussion questions after each guest speaker and presentation to further engage the 120 attendees and 300 online viewers at this conference.
Now, let's watch this short clip of one of our guest speakers, Caroline Joyner, who works at Public Policy and Amazon. She was presenting at this event.
Science high school, what about other engineering skills such as electrical, mechanical, CAD that students should be learning on as well?
We have a big focus on making sure that what's offered in CTE courses aligns to industry needs and making sure that CTE is high quality, aligns to high wage, high demand. A TTA is within that as well. Because the federal pumpkins dollars that I mentioned before, it's the federal funding that is provided for first student basis for CTE courses. Will now only go to courses that will align with high wage, high needs. So we should always focus on making sure those CTE courses on some of the things you mentioned are aligned to industry and are rigorous courses.
Our third annual conference was SACOT on the Hill in February 2019. We implemented the same process of training SACOT members to go and advocate to Texas legislators, and we had over 30 successful legislator meetings. The main bill that was a part of our platform this year was House Bill 341, which was a bill relating to funding for public school career and technology programs. We also held our first ever legislator open house where FLL, FTC, and FRC teams from Austin got to demonstrate their robots and help legislators and staffers learn more about what FIRST students do and our passion for STEM education.
In November of 2019, we hosted the SACOT Summit. Many FIRST teams joined us at the Capitol for conversations with legislators, industry professionals, FIRST Robotics board members, and members of the Board of Education. We engaged in discussions with these professionals, and students got to speak up and ask questions to our panelists. After the panel of professionals spoke about their STEM experiences, we did a panel flip and gave the audience an opportunity to hear from 4 high school FRC students so they could talk about what changes they would like to see in our STEM community. They gave the adults insight into how our education and experiences at the high school level really are. Students learned how they can use their voice to go about endorsing STEM bills and advocating for STEM education. And adults got to recognize how we feel on the other side.
Our most recent event was the First State Advocacy Summit this past February. We hosted a stream on First Update Now's Twitch channel and had teams from Michigan, North Carolina, Pennsylvania, Virginia, and New York speak on the advocacy they have done in their state. Over 449 viewers gain insight into how they can create state advocacy for their team and how they can make a big impact on their state government. Each team presented their own advocacy initiatives and participated in a discussion with our robotics team, FRC 2468's SACOT presidents. We also had 2 guest speakers from teams here in Texas who joined us at the event site to talk about the change they have seen through their advocacy as a part of SACOT. We saw great value and results in hosting this nationwide stream because we got to bring together many states from around the country, all with similar goals in their advocacy. And we reached so many more teams who are now inspired to start their own STEM advocacy programs too.
Currently, SACOT has more than 146 first teams involved in our advocacy program, with over 1,090 members. SACOT has also hosted over 83 legislative meetings. But the numbers don't tell the whole story.
The following video shows 3 very important pillars in our community. The First in Texas chair, Ray Almgren, the former president of First, Don Bossy, and Texas Representative Donna Howard. All 3 of them have spoken at multiple of our annual conferences, and in their interview, they emphasized how important SACOT is in building and connecting the FIRST robotics community.
I see SACOT as one of the key mechanisms in which we can have first teams, educating their state legislators and senators on what a great benefit a FIRST program is to the community and to the students that participate. So for me, the benefit of SACOT is a grassroots effort where team members from throughout the state are educating our communities on the benefits of FIRST.
Advocacy is really, really important to FIRST, and I genuinely appreciate all the time and effort and energy and just the interest and enthusiasm that you all show to help us sort of get the message of FIRST and get access to FIRST to more and more kids. What you're doing and helping our elected leaders understand the importance of FIRST, the value of FIRST, and the value of supporting FIRST is really important. What you're doing, learning how to speak to elected leaders, learning how to message kind of the experiences you've had and the value of programs like FIRST to those elected leaders, and helping to get their buy-in and commitment to join us as partners and to make these types of programs accessible and available to every kid everywhere in any school or any community is really, really important. And so I just want to say, on behalf of myself, but really on behalf of the whole FIRST organization, that I really, really appreciate what you're doing.
STEM is so important, and if we don't do this, it's at our own peril, because that is not only the jobs of now, but the jobs of the future.
Now that you've seen SACOT's past, let's discuss what you as members of your community can do to have your voice heard. Real change begins with going out and making a lasting impact. Let's start by introducing FRC 2468 alumni and the former 2018-2019 SACOT presidents, Anna and Jake.
Hi, Anna and Jake. We're so excited to have you on and hear what you have to say about the impact SACOT had on you and speak to the audience about any advice you have for them. Hi, Anna. We're going to begin with you. How are you?
Hi, I'm great. How are you?
I'm good. Can you tell us about your experiences with SACOT and what it meant to you?
Yeah, of course. Being a part of SACOT has taught me so much, from public speaking to learning about Texas government and to pitching and advocacy. My experiences with SACOT have helped me gain confidence in leadership, and by being a student-led and student-founded organization, it's challenged me to think creatively to get high school students involved in advocacy. As we plan conferences and events, researching for presentations and speaking with legislators has also taught me so much about STEM education in Texas and how important it is to spread STEM across the state. From the relationships I built with state legislators and other adults outside of robotics through SACOT, I learned effective communication and various other business communication skills. But I feel like SACOT has also had a huge impact on Team 2468. Since it started within our team, we had the resources and connections to really start off strong and kick it off. As one of the team's main outreach initiatives, SACOT has allowed us to build long-term relationships with numerous other first teams through our booth set up at competitions and by hosting statewide conferences. It has, not only taught our team advocacy, but also how to teach other students across the nation who are also passionate about STEM and want to start their own state advocacy organizations. 2468 members are encouraged to participate in SACOT events, which might have taught them more about STEM education and advocacy than they might have initially expected upon joining robotics in the first place. SACOT has definitely helped our team and every team participating in SACOT make a true impact on their local community and their state legislature.
Wow, Anna, that was some amazing insight into your experience in advocacy. The last question we have for you is, do you have any advice for anyone wanting to start advocating in the audience?
Of course. Yeah, I would say my main point to make is to contact your legislators and don't be afraid to contact them. I remember feeling so scared the first time I spoke to legislators because, I was just some high school student wanting to share my story. But that's exactly what made it so special, because being a high school student is refreshing for legislators. It helps them understand your own perspective as a STEM student. They're really interested in getting to know you, your story, and your ideas, and are almost always willing to help whatever goals you have. SACOT built strong relationships with our state legislators, and they were very excited and very interested in speaking at our conferences. Legislators really want to hear from students like us. But please remember, legislators are very busy and likely won't respond the first time you contact them, especially through email. So send several follow-ups and start off emailing several legislators in the first place. Because I'd say for like every 10 legislators you email, maybe a couple of them will respond, but not even until the second or third follow-up. Do not be discouraged if they don't respond immediately. They're not trying to ignore you. That's just because they're busy, and they definitely want to hear what you're saying. I'd also want to add that once you have a meeting, it's really important to be prepared before you talk to them. That includes, doing research on your topic, as well as looking to see if there's current bills and legislation related to your topic. Practicing mock meetings and, preparing questions they may ask. In addition, you want to make sure that you dress appropriately. We all dressed business formal during our meetings, the suits and blazers, So definitely prepare something they can also remember you by for the meeting, like a one-pager leave behind summary or something that they can hold on to. And especially after the meeting, you want to make sure you follow up with an email to thank them and include anything else that you might have talked about during the meeting. I definitely know it can be scary at first, but it gets easier every time. So just remember that the relationships you build will be so important to making real change in STEM education.
Thank you so much, Anna, for sharing your experiences in SACOT with us and our audience.
Of course.
Next, Jake, we're going to ask you a couple questions. So how are you doing?
I'm good, man. I saw a few 2468 people in the chat posting a bunch of stuff, so that made me smile. I love you guys.
That's awesome. Do you think you could tell us about some of your personal experiences with SACOT and how it impacted you?
Yeah, so similar to Anna, I got a lot out of SACOT because it taught me how to go and speak to people, how to really put myself out there. Because like Anna said, it seems really difficult at first to go talk to legislators, but I got to do it a bunch, and that's really cool. And now I'm really well spoken in comparison how I was before. I got to work with organizing people. I got to meet a whole bunch of people, and when I mentioned to people that, oh yeah, I've advocated to a few people up at the Capitol in Texas, they always go like, whoa, that's so cool. And they're right. It's really awesome, and it's really good for you. And you get to learn a lot of skills that I think a lot of people in robotics, like Anna said, didn't expect to learn, and now they're actually getting to do it. And it's so cool, not only for me to, get to learn that stuff, but to see other people learn it as well. And I thought that was one of my favorite parts about, being the president of SACOT, was getting to see all that happen. So, but that being said, Anna and I talked a whole bunch about how like it affected us. We started SACOT to affect all of Texas, And I think it's really cool that, we've gotten to share, we say, oh, we got to learn a bunch from it. But all these students in, Texas got to learn a whole bunch about how to go talk to these legislators and how to really make a difference. And when I say, make a difference, now we have what you guys said, 83 legislators who know so much more about STEM. And that's pretty cool considering a lot of the legislators we talked to didn't really even know what it stood for. They didn't know that STEM was the science, technology, engineering, mathematics, like acronym. And hearing them, kind of light up, seeing high schoolers talk about that was really cool. And noticing that like they were actually taking notes, they were learning stuff from us. And that plays huge into our future. And that's how SACOT had such a huge impact on Texas, was that these people are going to be making policies that are going to affect us for the rest of our lives, whether it be your kids when they're in school or your business when you're running a business or you're just an employee. And I know that for the people watching and all the people who are in robotics who aren't watching, they're probably going to end up in a situation where those policies are incredibly important to them. And us going and educating all of these legislators, it's really important now, but into the future, it's going to be even more important. So I think we'll see the impact get even greater as we go on and see more SACOT teams form. And I just love seeing you guys do your stuff. So.
Well, thank you. That's really nice. So we love to hear your unique perspective. But how do you think SACOT has impacted other first teams?
So as I mentioned multiple times, was that, other students on those teams get to have these awesome experiences. They get to learn all this stuff. But more obviously, we help these teams get outreach opportunities that they wouldn't have had otherwise. And that, is great for everyone, especially let's say, you got a small team that doesn't know what they're doing. They get to get involved with us and now they can have a bigger impact and they can get some outreach points, which is awesome for them. But even more important is some of the stuff with SACOT in a Box that we've been doing. You guys actually mentioned this in the video and presentation. We reached out to a bunch of other states and taught them how to make their own versions of SACOT. I know I talked to a team up in Colorado. I talked to the Trojanators, and you guys are out there. You guys are cool. And we got to help them learn how to make this organization, which again is a huge outreach opportunity for those teams. But it also, like I said, I learned a lot from making these, and now I got to go help, other students go make their own organization. They learned a whole bunch and they got a whole lot out of it just in straight up life experience. And I'm really proud that I got to do something like that. And hopefully, teams have noticed that we've had a big impact here.
Thank you, Jake. We loved hearing about the ways in which SACOT has impacted you, you and our state, and how SACOT's model can be used by any team that wants to start their own advocacy efforts.
Yeah.
So if you live in the Austin area, you may know about KXAN, the local news channel here. Jake and Anna had the opportunity to talk about SACOT on KXAN. Here's a small clip of them and our robotics team from the news segment. Let's take a look.
Today, high school students from across the state are at the Capitol telling lawmakers about the importance of STEM education. Today's event is being hosted by a group of Westlake High School students who are part of the STEM Advocacy Conference of Texas, or SACOT. In addition to showing off their robotic creations, teens are meeting with their local representatives and senators to advocate for more funding for STEM activities, as well as new technology for classrooms statewide.
I hope they'll understand that high schoolers are really invested in their own education and they want to make a difference in the world. We're hoping that they'll see that and they'll start to listen more to us. We'll build a bigger voice and they'll start to actually spread STEM and put it into legislation that they want certain courses to be in every school across the nation.
I'm sure seeing a group of high school students taking time out of their schedules and having like the courage to go and talk to legislators is just really impressive, and I think they will definitely hear more and want to hear more of what we have to say.
Definitely is impressive. This is the second legislative session SACOT has taken part in since it formed in January 2016.
So next, we're going to briefly recap on what Anna and Jake spoke on and share some more information so we can give you a perspective of the complete impact of SACOT.
So SACOT and STEM advocacy in general can impact you in numerous ways beyond just advocacy, but in other aspects of life as well. Students gain skills like leadership, public speaking, pitching, communicating, and more that help beyond just SACOT. And it's even a great resume builder for any high schoolers that are watching out there in the audience. Advocating to help pass a bill and see real change happen at the legislative level is truly such a fulfilling experience because you see the issues that you spoke up for being changed and improved due to your efforts. Also, meeting new teams and like-minded individuals when we come together to discuss important issues at our conferences and events is so much fun.
SACOT can impact your robotics team by providing an impactful and meaningful outreach activity that Even First loves. You can make connections with other teams and professionals at events, and you can collectively better your STEM community together.
SACOT has impacted over 146 FIRST teams and 1,091 individuals in just the state of Texas. Many of these teams have reached out to other teams in their community and area and spread the word about SACOT and even helped start their own STEM advocacy models. One of the bills that SACOT helped pass was Governor Abbott's Classroom Connectivity Initiative, which provides high-speed broadband and Wi-Fi to all K-12 Texas public schools. It's always rewarding to see real change like that happen when bills we advocate for are passed. After conferences, SACOT strives to have Texas teams take the skills they learned back to their local communities and continue to make change. It is crucial to keep having your voice be heard and to not stop until you see the results you desire.
So SACOT has not only helped fuel STEM advocacy in Texas, but we played a key role in starting advocacy programs in Pennsylvania and Arizona. Our former SACOT president was invited to the first Arizona Conference of Technology Advocacy's first conference through FRC 1165. They were there to present on the structure and organization of statewide advocacy programs. Additionally, we expanded our organization's model. We sent it to Pennsylvania with FRC 5740 and PACT, or the Pennsylvania Advocacy Conference of Technology. We also introduced 6 different advocacy models, like we mentioned earlier, to viewers across the country via our first state advocacy summit. We hope to continue expanding SACOT and our advocacy efforts across the entire nation, spreading the message and importance of STEM.
Now we would like to open it up for questions from the audience. You can leave any questions you have for us down in the chat.
All right, looks like we do have a few questions coming in. The first one is, what inspired each of you to, get into SACOT, and, what's the story behind it?
Rohi, do you want to go first?
Sure. So I've been a part of the outreach team on 2468 since my freshman year, and I've always seen SACOT as one of the most impactful and widespread initiatives of ours. And I was just so interested in what actually went on in the government here in Texas. So I decided to join the team last year, and I'm so excited to lead our team next year, especially with our annual conference coming up in February that hopefully we can have again this year.
So I joined SACOT because I was interested in how it all worked. It looked really fun seeing all my friends I know. They were going out to all these cool events. I also wanted to learn certain skills like how to use Streamlabs OBS. And I actually got to put some of those skills to use at our first state advocacy summit this past February.
I know Anna and I's story is probably going to be similar. Anna, do you want to tell it?
Sure. So Jake and I were actually the co-founders of SACOT when it first started. And as you may have heard Arohi and Mason talk about, it was the National Advocacy Conference. Our freshman year that summer, we went just to check it out and learn more about the government and how we can, pitch STEM education. And as we went to this conference, we realized, like, hey, why don't we do the same thing that they're doing, except on a more local level, on our state level, so that it's easier to impact real change. Since doing things on the federal level will take a lot of time, we decided to take it down a notch and really make it about Texas first and create our own Texas, advocacy organization, so we can really hit the parts about STEM education that we really want to change in Texas. You can add on more.
Yeah, the cool thing was it started when we were on the TAOs, FTC 5628, back 4 years ago, and we ended up doing NAC, and we had a bunch of people on our team who actually went to it, and we came back to that. We had a bunch of people going up to FRC, and we started working on exactly what Anna was talking about before we did our first conference, and we used all the stuff from 2468 to end up getting it done. So it was really cool. It started as this little idea where we just wanted to go advocate and see if we could do some cool stuff, and then we ended up starting this whole thing just in the course of a year.
Awesome. And since SACOT has grown to be an organization with so many team members from all around Texas, how do you guys keep up with each other and about upcoming events or like important dates, etc.?
So SACOT actually has a Discord server, and through this Discord, we communicate a lot and we talk about our upcoming events and new ideas for our organization. And if anyone here is watching from the state of Texas and is interested in joining, then you can reach out to us on social media, and we can definitely add you to our Discord server, because that is how we keep up with all of the events and talks going on. So yeah.
Awesome. Looks like that is all the questions we have. Do you guys want to wrap it up?
Sure. Let's wrap it up. So to recap, SACOT was started with the original idea of advocating for STEM education and bills by coming together with robotics teams from all around Texas and working towards increasing awareness and funding. We want to reiterate the fact that speaking up and advocating can lead to real change and progress, not only in our community or state, but even your nation. From our own experiences, we have seen that doing this can not only be a lot of fun, but truly a rewarding experience.
Thank you so much for everyone for attending and watching our presentation. We will be posting the slide deck on SACOT's website, so anyone who wants to view it can later. You can access our website by scanning the QR code. Oh, wait, I was pointing. You can access the website. It's in the bottom left corner. I'm pointing again. It's in the bottom left corner. It's the QR code. You can also visit by you can go to sacot.org. That's our website. Be sure to check out our social medias. They're right next to the QR code. And you can go to our social medias to find out more about SACOT, what we do, and our upcoming events.
Thank you everyone again, and goodbye.
Yeah, thanks for having us. Bye.
Thanks.
Thank you guys so much for that excellent presentation. Actually, personally to me, 2468 was the team that really showed me what FRC was about. The iconic chant, the stomping in the stands, the whole atmosphere you guys create is just amazing. And it's great to hear about all the good work y'all are doing down in Texas. So yeah, thank you guys so much.
Hell yeah, man. All right. Thanks for having us.
Thank you guys so much.
All right, that was an awesome presentation, but unfortunately, our time has come to an end. I hope you enjoyed these past 24 hours and the insightful presentations that have taken place. We hope you've enjoyed it as much as we did, and that this event taught you something new and also entertained you during these uncertain times. We have had over 100 people working on this event, from the presenters to the host teams. A huge thank you to everyone who gave their time and talents for this event, and also a huge shout out to teams 503, 1073, 3132, 4253, and 4481 for co-hosting this event with us. So until next year, this is Team 971 signing off, and have a great night.